Okay, lesson 5.8 is on absolute value graphs. You have two objectives for today. The first one is you want to graph an absolute value function, and the second objective is to translate the graph of an absolute value function. And an absolute value function is a V-shaped graph that opens up or down. A translation is where you shift that graph horizontally or vertically or both. So example 1, they want us to describe some translations. What we're going to do is, this is the graph of y equals absolute value of x. It starts at the origin, the slope of the right leg is 1, and then the left leg you get by symmetry. You can fold this leg over the y-axis and it'll match. They want to know how this graph is related to this graph. Well, the slope of the right leg is 1, but the vertex, or the pointy part of the V, is not sitting on the origin. It's actually sitting 1, 2 below it. And that minus 2 would tell you that as well. But the answer to this is that it's translated down 2 units. So you're going to write translated down 2 units. And all you have to do is look at the graph. It was at the origin, and we shifted it down 2 units, and that's what we've got here. You can also look from the equations. I've got y equals absolute value of x and y equals absolute value of x minus 2, and the minus 2 tells you it's going to translate down 2 units. Alright, guided practice number 1, I want you to try this on your own. They want you to tell them how this graph here is related to this graph here, because they're asking you y equals absolute value of x, which is this graph, and tell how it's related to each other. Okay, if you'll look, we have shifted our graph from the origin up 4 units, up 1, 2, 3, 4 units. So we're going to say translated up 4 units. The other thing we could have done is looked at our equation. We had, or they didn't give us the equation, so we can't look at that. Never mind. Okay. Then they say that the vertical translation happens when? It happens when you add or subtract outside of the absolute value bars. Okay, to graph a vertical translation, what you're going to do is first identify it. It's plus 2, so that's going to be up 2. If it had been minus, it would have been down. And we're going to start with the parent graph. And the parent graph always starts at the origin, and the slope of the right leg is 1, which means we're going to go up 1 over 1. And we're going to draw this little V. That's the right side of it. The left side of it's going to be symmetrical the other way. So if I have, since I have this point here, we're going to mirror it across the y-axis. And then it's going to go this way. And that's my parent graph. What we're going to do is graph this equation in pink. And we're going to take each point of the parent graph and we're going to shift it up 2. So we're going to go up 2 and put a point. And then we're going to do that for each one of the points on both sides of the absolute value graph. And then we're going to draw the V. So really the answer to my question is this pink graph right here. I just used the black part to get the answer. Okay, guided practice number 2, I want you to use the same coordinate plane, and I want you to graph y equals x minus 7. Absolute value of x minus 7. What I will tell you that you do is you're going to shift each point down 7 because of the minus 7. I'm not going to go over this one with you. We're going to take each one of these points and you're going to shift them down 7. So your V is going to be down here. The next thing we want to talk about is horizontal translations, and those happen when you add or subtract inside the absolute values, the absolute value bars. So, if you'll look at example 3, I've got plus 5 inside the bars. So that means I'm going to go either left or right. If I add inside the bars, I go left. But if I subtract, I go right. So I'm going to write add, left, subtract, right. And this tells us that we're going to shift this 5 units. The first thing we want to do is graph the parent graph. And this is not actually part of my answer because all my question said was what is the graph of y equals absolute value of x plus 5. But I'm going to do this to find my answer. So the first thing I want to do is graph my parent graph. The absolute value function always starts at the origin. And then the slope of the right leg is 1. So I'm going to go up 1 over 1. And I'm going to draw the right leg. Then the slope of the left leg is the exact opposite of that. So I'm going to go up 1, left 1. And I'm going to draw my left leg. That's my parent graph. The reason I drew it is because this graph is a translation of the parent graph that shifts it left 5 units. So I'm going to shift each point of my parent graph left 5 units. So the vertex point is going to be there. The slope of the right leg is still going to be up 1 over 1. I'm going to go ahead and graph that. And the slope of the left leg is going to be up 1, left 1. And the pink graph, this one here, is my answer. The black graph is just what we use to visualize how to shift it left 5. Guided practice number 3. I want you to use the same coordinate plane and graph this. I'm not going to graph it for you, but I will tell you that that plus 5 or the minus 5 inside the absolute value means you're going to move it right 5 units. So you're going to take this parent graph and you're going to shift every point right 5 units and graph a new absolute value graph. All right, example 4, we're going to graph a step function. It says the school will charter buses so that the student body can attend a football game. Each bus holds a maximum of 60 students. Make a graph that models the relationship between the number of students X that go to the game by bus and the number of buses that are needed. So first we're going to think about this. For 1 to 60 students, we're going to need 1 bus, right? And for 61 to 120 students, we're going to need 2 buses. And for 121 to 180 students, we're going to need 3 buses. And for 181 to 240, we're going to need 4 buses. So we're going to graph that. And the number of students is going to be my independent variable because it determines how many buses we need. And then the buses is going to be my dependent variable. And we're going to count by 60s. So 60, 120, 180, 240, 300. And buses will count by ones. 1 bus, 2 bus, 3 bus, 4 bus, 5 bus. Okay? Now, we are going to go from 1 to 60 with 1 bus. So for students 1 to 60, we're going to be at 1 bus. So we're going to put an open circle on 1 and a closed circle on 60, and we're going to do a line between them. And that represents from 1 to 60 students, we need 1 bus. Okay. Now, from 61 to 120, we need 2 buses. So we're going to put an open circle on 60, and we're going to go from 61 to 120, we need 2 buses. We're going to do a closed circle down here and an open circle on the left. Because this represents 60 students, so I don't put a closed circle at 60 students because it's already represented here. Now I'm going to come up here and put an open circle because it represents 120, so I'm not going to include it. And then I'm going to draw my line, and then I'm going to include 180 because any students from 121 to 180, I need 3 buses. Then we're going to do an open circle, and we're going to include 240. So that represents from 181 to 240, I'm going to need 4 buses. And you could keep it going, but that's what we call a step function because it looks like steps as you go up. Okay, you're going to need to bring your completed outline to class tomorrow and be ready for a quick quiz at the beginning of class.